So welcome back to my recorded classes. This video we are discussing the topic inverse of a matrix. This is the topic from the course Mathematics for IT. Let's start the topic. Section number 5.5, inverse of a matrix. So this section we are discussing how to find the inverse of a matrix. Okay, how to find the inverse of a 2 by 2 matrix and how to find the inverse of a 3 by 3 matrix especially. Okay, so before that, what is the meaning of inverse or multiplicative inverse. For example, if you are taking a number, okay, after that we will come to the matrix. For example, if you are taking a number 5, for example, okay, so this number we are calling x number. Now what is the meaning of multiplicative inverse is that when we are multiplying this number with another number, okay, answer should be equal to 1. Okay, so the second number we are calling the inverse of the first number. Okay, that means whatever the number we are getting here, this number we are calling the inverse of the first number. In the number sense I am telling. Okay, so what is the number here we are getting? For example, when we are multiplying with 1 over 5, 5 multiply 1 over 5, answer equal to 1, correct? Because 5 and 5 we can cancel, so answer we are getting equal to 1. So this number 1 over 5 we are calling the inverse of the number 5. Okay, so this is the basic idea of the inverse of a number, multiplicative inverse of a number. That means when we are multiplying a number with another number, okay, for example, here another number we are taken y, x multiply y, answer equal to 1. So the y number we are calling the inverse of the first number, or we can represent x inverse. Okay, x power minus 1, x inverse. So x inverse is 1 over 5. Now when we are coming to the matrix idea, okay, how can we find the inverse of a matrix? So you can see inverse of a matrix. If A is a square matrix of order n, and if there exists a matrix A inverse such that A multiply A inverse equal to I, equal to A inverse multiply A, then A inverse is called the multiplicative inverse of the matrix A. So very simple meaning. Okay, what we are doing, for example, what is the inverse of a matrix means, okay, when we are considering a matrix here, okay, for example, I am choosing a 2 by 2 matrix, calling it as A. Okay, for example, matrix 1, 2, 3 and 4. Okay, now when we are multiplying this matrix with another matrix, okay, we need to find what is this matrix, a 2 by 2 matrix, correct? So we need to multiply these two matrix. Answer should be equal to the identity matrix. Identity matrix means 1, 0, 0, 1. Okay, number case example I told you, 5 multiply 1 over 5 means equal to 1, correct? 1. 1 in case of matrix means it is same like identity matrix. This is we are calling identity matrix, or we are representing I letter. So what is the meaning we are telling? When we are taking a matrix A and multiply with another matrix we are calling A inverse, answer should be equal to the identity matrix. Then the second matrix we are calling inverse of the first matrix. So we need to find what is this matrix here. Okay, this is the basic idea we are doing. This is one example for the 2 by 2 matrix. Okay, now same way we can extend 3 by 3, 4 by 4, all the matrix ideas. Okay, square matrices. So a square matrix of order n, when we are taking, there exists a matrix A inverse. Okay, inverse of the matrix A. What is the condition for that? When we are multiplying A matrix and A inverse matrix, answer should be I matrix. I means the identity matrix, correct? When we are multiplying A matrix and A inverse matrix, answer should be the identity matrix, I matrix. Okay, this is I. So what is the meaning of I? I means the identity matrix. For example, identity matrix order 2 means, we discussed it in 5.1 section, I2, identity matrix order 2. What is that matrix? 1, 0, 0 and 1, correct? Now same way identity matrix order 3. What is the identity matrix order 3? That means 1, 0, 0, 0, 1, 0 and 0, 0, 1, correct? This is the identity matrix of order 3. Okay, same like we can extend. What is the identity matrix of order 1? That is matrix 1, correct? Matrix 1. So when we are multiplying A matrix and A inverse matrix, answer should be equal to the identity matrix. Okay, so depends on the matrix what you are taking. If you are taking 2 by 2 matrix, I means 1 0 0 1. If we are taking 3 by 3 matrix, 1 0 0 0 1 0 0 0 1. So this second matrix we are calling in A inverse is called the multiplicative inverse of the matrix A. Now this section what we are discussing, discussing is that how to find this A inverse matrix. How to find this A inverse matrix such that A multiply and A inverse matrix. If we are multiplying these two matrix, it should be the identity matrix answer. Okay, so what is this matrix? We need to calculate what is this A inverse matrix. So what we are doing is, first we are considering A matrix is 2 by 2 matrix. How can we find the inverse of a 2 by 2 matrix? After that, one or two example we will discuss how to find the inverse of a 3 by 3 matrix. Okay, so here first we are doing the shortcut method 2 by 2 matrix inverse. How to find the inverse of a 2 by 2 matrix? For example, I have a matrix A here. A equals matrix A, B, C, D. It is a 2 by 2 matrix, correct? 2 rows and 2 columns. Then this shortcut method, using this shortcut method, we can find the inverse of the matrix firstly. That means A inverse equal to 1 over determinant of A. You know how to calculate a determinant of A. So 1 over determinant of A multiply main diagonal interchange. You know what are the main diagonal number? That means A and D. These two are the main diagonal number. Interchange that two number. That means D we are writing first, A we are writing last. Okay, as you given here. And off diagonal numbers put opposite sign. B you write minus B. C we need to write minus C. Okay, so this matrix we are calling inverse of the first matrix, A matrix. A inverse equal to. So this is the rule or shortcut for finding the inverse of a 2 by 2 matrix. So we will go to some examples. Okay, then we will come back to the 3 by 3 after that. So how to find the 2 by 2 matrix inverse? First we will discuss exercise 5.5. Find the inverse, A inverse of the following matrices. For example, A matrix is given here. A matrix is A equals, I can take that matrix as A. So A equal to matrix minus 5, 7, 2 and minus 3. This is the A matrix. We need to calculate what is the A inverse, multiplicative inverse of the matrix A, correct? A inverse equal to. So for finding A inverse matrix, what we are doing? First we are calculating what is the determinant of this A matrix. Determinant of A equal to. We already studied before section, 5.4 section, how we are finding determinant of this matrix, correct? Main diagonal number multiply. That means minus 5 multiply minus 3 minus off diagonal numbers multiply. That means 2 multiply 7. So you can check the answer, correct? 5 multiply 3 minus 5 multiply minus 3 means 15. Minus 2 multiply 7 means 14. So answer will be equal to 1. So determinant equal to 1. We will get determinant equal to 1. Now we are writing what is the inverse of that matrix. Okay, so A inverse equal to, A inverse we are representing this notation, A power minus 1. So A inverse equal to what we are discussing in this shortcut, 1 divided by determinant of A, correct? So we can write 1 divided by, what is the determinant of A? It is 1. Multiply main diagonal numbers of the matrix interchange. What are the main diagonal numbers? Minus 5 and minus 3. We can interchange these two numbers. So minus 3 we are writing first. Minus 5 we are writing last. Off diagonal numbers put opposite sign. Correct? For example, 7 we are writing minus 7. Opposite sign. And 2 we are writing minus 2. Opposite sign. Okay, I hope you understood. Now after that what we do, this outside number 1 over 1 we can multiply with the first number, multiply with the second number, third number and last number, so that we will get what is the inverse matrix. So we can write A inverse equals, actually 1 over 1 means what is the number? Same 1, correct? So 1 multiply minus 3 means minus 3, 1 multiply minus 7, minus 7, 1 multiply minus 2, minus 2, 1 multiply minus 5, minus 5. Okay, so this is the inverse of that 2 by 2 matrix A. Okay, so this is the inverse matrix. I hope all of you understood how to calculate A inverse matrix, 2 by 2 A inverse matrix, correct? So it is easy only. Now we will discuss one more example. Find the inverse, A inverse of the following matrices. Okay, matrix 6, 4, minus 2 and 3. So first we are taking the given matrix as A. A equals matrix 6, 4, minus 2 and 3. Given matrix we are taken as A matrix. Now we are going to calculate the A inverse matrix. So before that we need to calculate what is the determinant of A. Determinant of A equals, what is the determinant of A here? Main diagonal number multiply 6 multiply 3 minus off diagonal numbers multiply minus 2 multiply 4. Correct? So 6 multiply 3, 18 minus 2 multiply 4, minus 8. Correct? So we can write 18 plus 8. Correct? It is equal to 26. So we can write equals 26. So I hope you understood how to find the determinant. Now we will write what is A inverse. A inverse matrix equal to. Okay. So we can write what is A inverse matrix equal 1 divided by determinant of A. What is determinant of A? 26. Multiply main diagonal numbers interchange. Correct? What are the main diagonal numbers? 6 and 3. We need to interchange these two numbers. Correct? So we can write 3 first, 6 last. Just interchange that two number. Okay. Now off diagonal numbers we need to put opposite sign. So instead of 4 we are writing minus 4. Instead of minus 2 we are writing plus 2. Opposite sign. Okay. Now after that we need to multiply 1 over 26 to inside the matrix, the first number and second number. So A inverse matrix equal. Okay. So first 1 over 26 multiply 3. See, like 1 over 26 multiply 3. So just multiply the numerator number. 1 multiply 3, that is 3, divided by 26. We can write same, 3 over 26. Now 1 over 26 multiply minus 4. Correct? So 1 multiply minus 4 divided by 26. Now 1 over 26 multiply 2. Correct? So 2 over 26. 2 over 26, or we can write 1 over 13 like simplified 1. Okay, or you can keep it same. Now 1 over 26 multiply 6. Okay, so 6 over 26. So this is the inverse of the matrix A. So how to find inverse? I hope you understood. It is easy only. 2 by 2 matrix case. You can use the shortcut idea. Okay, we will go to the next question. Question number 2. If A equal to, okay, if A equal to matrix 4, 3, 5, minus 1, show that A inverse transpose equal to A transpose all inverse. Okay. So what is the question? A1 matrix is given. Okay. What we need to show? Show that. Show that means first we need to calculate this left hand side. This is left hand side, LHS. Okay. And then calculate the right hand side, RHS. Okay. Both sides should be same. That means left hand side should be same as the right hand side. That is the meaning of that. Show that. So we need to do separately here. So first we will do what is the left hand side. Then we will go to right hand side. Okay. So first we are doing left hand side of the equation, and then we do what is the right hand side of the equation. Then we will check both are same or different. Okay, left hand side same as right hand side or not. So left hand side first we will check. What is the left hand side we need to do? A inverse matrix transpose. First we need to find A inverse, then we need to find the transpose. See, A inverse first we calculate. We studied how to find the A inverse of a 2 by 2 matrix. Then that matrix transpose we need to calculate. This is the left hand side. What is the right hand side? In right hand side, first we need to calculate A transpose. You know how to find the transpose of a matrix, correct? Just write the rows in column wise. Then after that, this matrix inverse we need to calculate. This is the right hand side. So once we calculate right and left, okay, just to check you are getting same matrix or not. It should be same. That is the meaning. Show that. Okay. So we will check one by one. So first we will start with the left hand side. First we are finding A inverse matrix. So first to find what is determinant of A. Determinant of A means 4 multiply minus 1 minus 5 multiply 3. main diagonal number multiply minus off diagonal number multiply. So you can check what is the answer getting. Minus 4 minus 15, correct? So minus 4 and minus 5 multiply 3, 15. So minus 19. We will get minus 19. Okay, now write what is A inverse. A inverse matrix equal 1 divided by determinant of A is minus 19 multiply matrix main diagonal number interchange and off diagonal number put opposite side, correct? So main diagonal number we are interchanging, minus 1 writing here, 4 writing here. Off diagonal number 3 becomes minus 3, 5 become minus 5. Okay, now after that 1 over minus 19 you can multiply to the inside. So what we are getting the matrix? Matrix first number minus 1 by minus 19 multiply minus 1. So 1 over 19, because that minus minus will cancel, 1 over 19 we will get, like 1 over minus 19 multiply minus 1, like this, correct? So 1 multiply minus 1 divide minus 19 same. So this minus minus will cancel, you will get 1 over 19. Now second number minus minus will cancel, 3 over 19. Third number 5 over 19, minus minus will cancel again, so we will get 5 over 19. Then the fourth number minus 4 over 19, the minus will not cancel, only one minus, so minus 4 over 19, correct? This is the A inverse matrix. Now what we need to do now? A inverse matrix transpose we need to calculate, correct? Now A inverse all transpose, this is the left hand side, transpose matrix equal to matrix. You know how to calculate the transpose? Write rows in column wise. First row write first column. So 1 over 19 and 3 over 19. This will be the first column. First row we are written first column. Second row, that means 5 over 19 and minus 4 over 19. Write it as second column. So this is the transpose of the A inverse matrix. So we got the left hand side now. Now we will go to the right hand side of the equation. After that we can verify it is same or not. Okay. So we will go to that one, right hand side. So first right hand side, what we need to calculate first? A transpose, correct? A transpose matrix first we need to calculate. Matrix, okay, the original matrix, A matrix transpose. What is the A matrix? 4, 3, 5 minus 1. That matrix transpose. So first row 4, 3, write it as first column. Second row 5 minus 1, write it as second column, correct? Now A transpose matrix inverse we need to calculate. This matrix inverse, correct? This matrix inverse. So first we need to calculate what is the determinant. Determinant of the A transpose matrix, okay, equals, what is the determinant of this one? 4 multiply minus 1 minus 3 multiply 5, correct? You will get minus 19. The same as determinant of A, because we are studied before, determinant of A and determinant of A transpose should be same. Okay, so minus 19. Now we need to calculate A transpose matrix inverse now. Okay, so A transpose matrix inverse equal, okay, 1 over determinant of A transpose matrix is minus 19 multiply matrix main diagonal number interchange, off diagonal number put opposite side. A transpose matrix, okay, don't forget A transpose matrix. So minus 4 and minus 1, how we are interchanging these two number? Interchange this number and this number, correct? So minus 1 will come first, 4 will go to the last. Off diagonal put opposite sign, 5 opposite sign minus 5, 3 opposite sign minus 3, okay? So we will get, this is the inverse. Now 1 over 19 we can distribute to the bracket. So distribute to the matrix. So what will be the first one? 1 over 19, because minus minus will cancel, 1 over 19. Second one 5 over 19, correct? Minus will cancel. Then 3 over 19, minus will cancel there. Then minus 4 over 19. I hope you understood how we are getting. Just to multiply that outside number to inside. Okay, so we got the right hand side also now. Now check right hand side and left hand side are same or different. Okay, you can see that one. Yes, It is same because 1 over 119, 1 over 19, 5 over 19, 5 over 19, 3 over 19, minus 4 over 19. So both sides are same. So we can write left hand side equal to the right hand side. So this is what our question. Show that left hand side value matrix same as the right hand side matrix. Okay. So this is the question here. I hope you understood. You can practice that question one more time for understanding more. Okay, now we will come to the question number 3. Show that any matrix of the form 0 k 1 over k 0. For example, I am taking that matrix as A equal to matrix 0 k 1 over k and 0. Show that any matrix of the form 0 k 1 over k 0 is its own inverse. What is the meaning its own inverse? Its own means when we are calculating inverse of this matrix, inverse will be same. That is the meaning its own inverse. Okay, that means we need to check A inverse. When we are calculating, you will get same as A matrix or not. That is the meaning its own inverse. Okay, so just to check what is the inverse of this matrix. Okay, so first we need to check what is the determinant of A. What is the determinant? Main diagonal number 0 multiply 0 minus off diagonal number 1 over k multiply k. Okay, so what will be the answer? 0 multiply 0, 0 minus, here 1 over k multiply k means this k and k will cancel. So minus 1. So what is the determinant? Equal to minus 1. Okay, now write what is A inverse matrix. A inverse equal to, what is the shortcut? 1 divided by determinant of A minus 1 multiply main diagonal number interchange. So here 0, here also 0 because both diagonal numbers are 0. Off diagonal put opposite, k opposite minus k, 1 over k opposite minus 1 over k. Correct? We will get like this. Now 1 over minus 1 we need to multiply to the inside this number. First number multiply, second number, third and last. Okay, so we can check it. What is that matrix getting? Equals matrix 1 over minus 1 means minus 1. So minus 1 multiply 0, 0. Minus 1 multiply minus k, that is k. Minus 1 multiply minus 1 over k, 1 over k. Minus 1 multiply 0, again it is 0. So this will be the answer. Now we can see this answer. Is it same as the given matrix? Yes, it is same as the given matrix. Correct? 0 k 1 over k 0. So that means inverse is same as the question matrix. Same matrix, A matrix. Correct? So A inverse is same as A matrix. So what is the meaning of that one? Its own inverse. Its own inverse. That is the meaning of its own inverse. When we are calculating the inverse, we will get the answer same as the original matrix. Okay, so A inverse same as A. So that is the question idea here. I hope you understood how we are calculating 2 by 2 matrix inverse. Okay, now there is one question, question 4. Check whether the inverse A inverse of A equal to minus 1 to 4 minus 8 exists or not. Inverse, we can find inverse or not. We need to check that one. So we will see that one. What is the determinant? Determinant of A equal minus 1 multiply minus 8 minus 4 multiply 2. Correct? Minus 1 multiply minus 8 means 8 minus 4 multiply 2, that also 8. 8 multiply, sorry, minus 8, 0. Correct? Determinant 0. Determinant 0 means what happening there? Inverse doesn't exist because you know A inverse, when we are writing 1 divided by determinant A, 1 divided by 0, it is correct, not defined here. Correct? Other part are all okay, whatever here not a matter. 1 over 0 not defined. Correct? We can write this part is not defined. Correct? Not exist. So 1 over 0 not exist. So determinant A 0 means inverse not exist. Correct? Inverse not exist. Directly from here itself we can write inverse is not exist if determinant A equal to 0. So this is the conclusion here. See, A matrix, you remember singular matrix in previous section we are just discussed the idea. If a matrix is singular or non-singular, what is the meaning? Singular means if a matrix is singular, then determinant value you will get to 0. If non-singular, determinant not equal to 0. Non-singular not equal to 0. Now singular means what is the meaning? Determinant is 0, correct? Determinant 0 means what is the meaning? A inverse not defined. See, just before question, see here determinant is 0. That means A inverse is not defined, not exist, correct? So that is the meaning, A inverse not defined. Singular matrix, A inverse is not defined. So A inverse is defined when it should be non-singular. Determinant should be not equal to 0. 0 value, inverse is not defined. If it is not equal to 0, A inverse is defined there. Okay, so this is the basic idea when we are finding the inverse of a matrix. Now, we will come to the 3 by 3 matrix now. How to find the inverse of a 3 by 3 matrix. Okay, this is lengthy procedure. Just I am practicing for your understanding. Okay, 1 or 2 questions. How to find the inverse of a 3 by 3 matrix. Okay, how to find the inverse of a 3 by 3 matrix. Okay, now just I will start the procedure. All of you remember the procedure row transformation we are studied in 5.2 section and 5.3 section. Row transformation. So using row transformation, we are using row transformation for finding inverse of a 3 by 3 matrix. Okay, general method we are using here. 2 by 2 means we can use the shortcut method to find the inverse. Now 3 by 3 we are going to find. So what we are doing is just starting from A and I matrix. I means the identity matrix. Okay, A matrix and I matrix. So here we are calculating inverse by using row transformation. So AI equal to the matrix. Write A matrix first. Whatever the matrix is given, that is the A matrix. 1, minus 1, 1, 0, 2, minus 1 and 2, 3, 0. Okay, you can put a line. After that you write I matrix. What is the I matrix? I matrix is the identity matrix. 3 by 3 identity matrix, because here the question is 3 by 3. So what is the 3 by 3 identity matrix? 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so 3 by 3 matrix inverse we are starting from here, this step. Okay, it is little lengthy procedure. Now start from here. Now after that we are changing the A matrix into I. Last we need to get the answer. First matrix we need to change into the identity matrix. Now whatever the answer we are getting in the second part, that is the inverse matrix, A inverse matrix. Okay, we need to do like this procedure. So we will go to this procedure one by one. So that you will understood how we are doing. So what we do is first check the first number. This number should be 1. This number we are calling the pivot number. This number should be 1 number. Here it is already 1, correct? You know, if it is not 1, how we are doing? We are studied in 5.2 section, row transformation. Same idea here. Now 1 down number we need to make 0. Here it should be 0. Here it should be 0. So this number and this number should be zeros. This is the second step. Already the second down number is 0. So no need to do anything there. So the third row we need to change, correct? This is the first row, second row and third row. Third row we need to change here. So if you want to change a number 0, you are studied in 5.2. What is the procedure? Row 3 we are changing. So R3 plus is default. Opposite of the number 2. Opposite of number 2 means minus 2. Multiply pivot number coming row. Pivot number is coming which row? First row, correct? So multiply R1. Minus 2 R1 plus R3 gives new R3, correct? Now we use this transformation, write the equivalent matrix. Equivalently matrix, you can clear one by one. It's lengthy procedure. So minus 2 R1 plus R3 gives R3. So you can check this one in your calculator. This one, minus 2 times R1 plus R3. So you can type like minus 2x plus y in your calculator. You remember this procedure before. X means the first row. First row we are calling x. What is the first row here? 1, minus 1, 1, 1, 0, 0. Correct? 1, minus 1, 1. Then 1, 0, 0. Correct? Full row. Then y means the third row. R3 means y. What is the third row here? 2, 3, 0, 0, 0, 1. Okay, now we need to calculate like minus 2x plus y. Okay, minus 2x plus y. Okay, so you need to use the calc button as we discussed in 5.2 section. If you want to understand detail, you can go to 5.2 section. So calc button, so calculator will ask what is your x number, 1, press equal to. After that, calculator is asking what is your y number is 2. So once you enter, you will get the number 0 here. Same, we are finishing all the numbers. Okay, so I will write the answer here. So first row no change, we are writing the same, 1, minus 1, 1, 1, 0 and 0. Then second row no change, 0, 2, minus 1, 0, 1 and 0, correct. Now third row we are changing using this procedure, minus 2x plus y. You will get the answer like 0, 5, minus 2, minus 2, 0 and 1. Okay, we will get this answer. Now once you finish this idea, after that what we will do, this number, diagonal number should be 1. Here it should be 1 now. Okay, this number should be 1. So what we will do, we need to change the second row, correct, second row. What we will do, second row full number divided by the same number, divided by 2. R2 divided by 2 gives new R2. So I will write the equivalent matrix, equivalently matrix. Okay, first row no change, only second row complete number we need to divide by 2, correct. So first row I am writing same, 1, minus 1, 1, 1, 0 and 0. Okay, then second row complete number we divided by 2. So 0 divided by 2, 0. 2 divided by 2, 1. Minus 1 divided by 2, minus 0.5, correct. 0 divided by 2, 0. And 1 divided by 2, 0.5. Then 0 divided by 2, that is 0. Complete row divided by 2. Now third row same. What is the third row? 0, 5, minus 2, minus 2, 0 and 1. Okay, I hope you understood this step. That means now we go to this number is 1. This number now the pivot number. Okay, pivot. Now pivot number coming which row? It is on second row now, pivot number, correct. Now what we do, pivot number, down number and top number should be zeros. So here we need to make 0, here also we need to make 0. This should be 0 and this number should be 0. Pivot number, down number and up number should be 0. That means which rows we need to change? First row we need a new first row, new output row, and third row also we need to change as new output row. So R1 changing means R1 plus is default, opposite of minus 1, that is 1. Multiply pivot number coming row, that means second row. 1 multiply R2 plus R1 gives the R1, and same here opposite of 5 minus 5, multiply pivot number coming row is second row plus R3 gives new R3. Okay, I hope you understood the operation that we discussed in 5.2. So equivalently matrix, equivalently the matrix we can write, we need to change the first row using this row transformation, 1 multiply R2 plus R1, and third row we need to change by using this transformation, minus 5 multiply R2 plus R3 gives new R3, correct. So we will get the answer like, I will show the steps if you want on the next slide. 1 multiply R2 plus R1 plus R1 gives new R1, correct. So what is the meaning? We discussed in 5.2. This is the new input. Okay, this is the new output row, new output first row. Okay, so what you do, just enter in your calculator 1 multiply x plus y. X means the second row, correct. What is the second row? The second row is 0, 1. I will write little bigger here. So x means the second row. That means 0, 1, minus 0.5, then 0, 0.5, 0, correct? Y means the first row. It is easy when we are doing calculator. What is the first row? 1, minus 1, 1, then we will get 1, 0 and 0. Now calculate 1 multiply x plus y, correct? X plus y, that is x plus y. So when we are doing this operation in your calculator, you can press calc button. So calculator will ask what is your x number, 0, y number 1. So you will get the answer here 1, correct? Now again calc 1 and minus 1, you will get 0. Then calc minus 0.5 and 1, correct? Minus 0.5 and 1. That means you will get it the number again. There also 0.5. Then calc 0 and 1, you will get 1. Then calc 0.5 and 0, 0.5, then 0. So this is the new first output row. Okay, so we can write here. First row become 1, 0, 0.5 and 1, 0.5 and 0. Okay. Second row, there is no change. We can write same 0, 1, minus 0.5, 0, 0.5 and 0. Okay. Now third row we need to use this transformation, minus 5 times R2 plus R3. Okay. Whatever we did here, same idea we need to do next transformation. Minus 5 times R2 plus R3 gives new R3, new third row. Okay. So when you are entering your calculator, you can enter minus 5x plus y, where x means the second row and y means the third row, correct? Then you can calculate what is minus 5x plus y. Okay, same like before. Okay, so you know already the transformation now. Second row means what was the second row here? 0, 1, minus 0.5, 0, 0.5 and 0. Third row becomes 0, 5, minus 2, minus 2, 0 and 1. So you will get answer once you are using calculator. You will get answer like 0, 0, 0.5, minus 2, minus 2.5 and 1. Okay, so I will write that one. So we can 0, 0, 0.5, minus 2, minus 2.5 and 1. Okay, this number. So we got the second column also correct one. So first number 1 here. Then we change this number 1, down number 0, up number 0. Now we will go to this one. Here it should be 1 now. Okay, this position it should be 1. This is the next operation we need to do. Okay, that's why it is little lengthy the procedure. So equivalently the matrix, first row no change. Okay, what we will do for making here 1, third row we need to change. Correct? What we do, third row divided by same number 0.5. Third row divided by 0.5. So what answer we will get? First row 1, 0, 0.5, 1, 0.5 and 0 and 0, 1, minus 0.5, 0, 0.5 and 0. Then last row 0, all the number we need to divide by 0.5. 0 divided by 0.5, 0, 0 divided by 0.5, 0, 0.5 divided by 0.5, 1. Minus 2 divided by 0.5, we are getting minus 4, here minus 5 and 2, correct? So it is clear now, here the number is 1. Now this is the pivot number, correct? Now pivot number coming on third row. This is on third row now. Now pivot number, top number should be 0. Now here we need to change, these two numbers should be zeros. This is the next idea we need to do. So first row we need to change and second row we need to change. So what is the transformation we are using? R1 plus is default, opposite of 0.5 minus 0.5 multiply pivot number coming row, third row, correct? Third row, pivot number is coming on third row now. Same here, opposite of minus 0.5
it is 0.5, multiply pivot number coming on third row plus R2 gives new R2. So this operation we will do here. Okay, so what answer we are getting equivalently I am writing here, you can check by calculator. Equivalently we will get matrix 1 0 0, then the next part like 3 3 minus 1. You can check later by using calculator with when we are doing. Okay, 0 1 0 minus 2 minus 2 and 1, and 0 0 1 minus 4 minus 5 and 2. Okay, I hope you understood this one. Now we finished almost the idea. Okay, so what idea we did now? Okay, you can see in brief. So what idea we are, okay, we did. So first number we make 1 first. After that, that 1 number down numbers we changed zeros, correct? After that what we did, this diagonal number we changed into 1. Then diagonal number, top number and down number we changed 0, correct? After that what we did, this diagonal number we changed 1. Okay, then top number we changed zeros, this number 0, this number changed 0. So equivalently here also it will change, this part also it will change. Okay, here also all the numbers will be changed. So whatever the answer you are getting here last, okay, this matrix we are calling A inverse matrix. Okay, so once we make this part, okay, clear, once we make this part as identity matrix, this is identity matrix now, 1 0 0 0 1 0 0 0 1, whatever the answer you are getting this part, this is the inverse matrix, A inverse matrix. Okay, so we will write the answer here now. See here, this part now it is identity matrix, identity matrix. Okay, so whatever the matrix here we are getting, this is the A inverse matrix. Okay, so equivalently we can write like first matrix is identity matrix and second matrix is A inverse matrix. Okay, we are ending like this. Now we will write the answer last step, what is A inverse matrix, because our question is find A inverse, correct? Our question is find A inverse of the following matrix. This A matrix inverse, what is the inverse matrix? Now we got, we can write matrix, only we write the second part, 3 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 and 2. This matrix we are calling inverse of that A matrix, 3 by 3 matrix. Okay, so 3 by 3 inverse finding little lengthy, we need to practice more questions. Okay, I hope you understood the idea. One more question we will practice same way. Find the inverse, A inverse of the following matrix. Question number C. I am writing only the last matrix. You can practice with using calculator this question later when we are, okay, solving. So we will start this one. This is the matrix A, 2 minus 1 0 0 1 1 1 0 1. So start with which matrix? A and I matrix. Okay, equal matrix. What is A? 2 minus 1 0 0 1 1 1 0 1. Then identity. What is identity? 1 0 0 0 1 0 0 0 1. Okay, started with this one. Now what we need to do? First number should be 1 here, correct? But here it is not 1, it is 2. But the same column here number 1 is there, correct? This is the first row, this is the third row, correct? So if it is 1 coming downside, means you can interchange that rows. R1 you can interchange with R3, so that you are getting 1 number first. Okay, it should be 1 in the first position. So equivalently matrix, how can we write interchanging? Third row completely interchange to first row. So 1 0 1 0 0 1. Second row same, 0 1 1 0 1 0. Then first row we are writing third row, 2 minus 1 0 1 0 and 0. Okay, just interchange first and third. Now you can see the first number is 1 here, so our pivot number is 1 now. Okay, pivot number should be 1 there. Okay, that is why we are interchanged, this number should be 1. Now pivot number down number should be 0. Here already it is 0. This also we need to change into zeros, these two number. Now pivot number, keep in our mind, coming on the first row. So second row we need to change. No need to change second row, correct, because already it is 0. Third row we need to change. Third row. So how to make 0? You know, R3 plus is default. Opposite of 2 is minus 2. Multiply pivot number coming row is first row. Minus 2 R1 plus R3 gives new R3. So I will write the answer here. You can check the calculation yourself. So answer is equivalently the matrix. Equivalently the matrix. Okay, what are the row we are changing? Only third row. First and second same. Okay, so we can write the first row here 1 0 1 0 0 and 1. Second row also same 0 1 1 0 1 0. Third row we need to do that transformation. You will get 0 minus 1 minus 2 1 0 minus 2. You can verify later. Okay, so first row first number is 1, down number 0. Now we are going to here, this number should be 1. Already it is 1, so no problem. So this number is the pivot number. Pivot number is coming on second row. Now what we need to do? Pivot number, down number and top number should be 0. So here it should be 0. Top also it should be 0. That is already 0. So only we need to change the third row here, correct? Third row. So how to make that number 0? R3 plus is default. Opposite of minus 1, 1. Multiply pivot number coming row, second row. You can do this operation. I will write the answer here. Equivalently matrix. Okay, what we are getting? First row no change. 1 0 1 0 0 1. Second row no change. 0 1 1 0 1 0. Third row we need to use this transformation and we need to write the answer. We will get like 0 0 minus 1 1 1 and minus 2. You can verify that one. Okay, now again what we need to do next step. So here we changed 1 first, then here changed 1, up number down number 0. Now here we need to change this number as 1. This is the pivot now. Okay, so what we need to do? We need to change the third row again. Third row divided by same number. If you want 1 divided by the same number, minus 1. So what we will get? Equivalently the matrix. First row same 1 0 1 0 0 1. Second row same 0 1 1 0 1 0. Third row complete number divided by minus 1. 0 divided by minus 1, 0. 0 divided by minus 1, 0. Minus 1 divided by minus 1, it is 1. Correct? And 1 divided by minus 1, minus 1. 1 divided by minus 1, minus 1. Minus 2 divided by minus 1, that is 2. I hope you understood. So now this number is the pivot number. Correct? Pivot. Pivot number should be 1. Now pivot number coming on third row. Now pivot number top numbers, it should be zeros. So this should be, these two numbers should be zeros. This is the next idea we need to do. So which rows we need to change? First row we need to change. Second row we need to change because both number we need to see 0. Okay, so R1, how to change? R1 plus is default. Opposite of 1 minus 1. Multiply pivot number coming on third row. Okay, same way, opposite of 1 minus 1, multiply pivot number coming third row plus R3 gives new R3. You can check these two transformation answer by calculator. So equivalently we will get the matrix. Okay, you will get the matrix I am writing here. First row you will get 1 0 0 1 1 and minus 1. Okay, use that transformation. Minus 1 multiply R3 plus R1 gives R1. Okay, and second row change, second row change by using this transformation here, R2, small mistake is there here. Okay, this is R2. R2 we are changing, second row, not R3, so R2. So once you use this transformation, you will get the matrix 0, 1, 0, 1, 2 and minus 2. You can verify that one. Okay, later. Third row same, 0, 1, 0, 0, 1, minus 1 and 2. So now we finished all the task. Okay, first number is 1, down number 0, then this number is 1, up number and down number 0, then this number is 1, up number is 0. So this matrix is now identity matrix, correct? Then this matrix we are calling A inverse matrix. Okay, so this is we are getting matrix I and A inverse. Okay, so what is the A inverse matrix we are writing? A inverse equal to matrix 1, 1, minus 1, 1, 2, minus 2, minus 1, minus 1 and 2. This is the inverse of the 3 by 3 matrix. Okay, so 3 by 3 matrix inverse is little hard. I hope you understood both 2 by 2, how to find the inverse of a 2 by 2 and 3 by 3. 2 by 2 matrix we can use the shortcut method, whatever we are discussed before, this shortcut idea. A inverse equal to 1 by determinant of a matrix, main diagonal number interchange, of diagonal numbers put opposite sign, correct? 3 by 3 we need to use the row transformation for finding the inverse of the matrix. So I hope you understood the inverse section 2 by 2 and 3 by 3. Thank you for watching this video. Please subscribe my channel. Thank you.